Good evening to all of you. Today I'm going to discuss topic of the probability where I have already given a link in video number 1. This is my continuation of the video. Today I will explain to you about the probability. There are 4 models in the probability and now we are going to discuss the probability cards model. Cards, as all of you know, a deck of cards have 52 cards in which there are king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 and as. So these are a set of 13 cards. Like this we have 13 more cards with king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 and as. Again we have with red color and green color, you are seeing where I have represented 4 different varieties of sets, that is 13 cards into 4, that is 13 into 4, total we have 52 cards. Coming to the probability, you may have a doubt, what is the use of these cards in probability, where we are going to use this. So we use the probability in daily life when we don't know for sure what the outcome will be for any situation. Meteorologists, for instance, use weather patterns to predict the probability of rain. Probability can be used in asteroids or for asteroid impacts, like an asteroid of size more than 200 meters has a chance of hitting 1 in 2 million chance to hit the earth. Probability always lies between 0 and 1. Sum of all the probabilities of all the possible outcomes is also 1. Example in cricket, in weather reporting and political election results, we can just use the probability. Here the probability of cards, let us discuss now. So total king, queen and jack are called as face cards. There are 3 face cards in a set of 13. So total there are 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards, and remaining are called as non-face cards. So total we have a deck of 52 cards, in which if you see properly there are 4 kings, 4 queens, 4 jacks, 4 as. Now coming to these 52 cards, how the questions will be in cards. If you just check, I am having 52 cards in my hand. What is the probability of picking of 2 cards which are either kings? What is the probability of picking 1 card which may be queen, which may be a number 3? So probability is nothing but selecting and picking of number of cards. Now coming to the actual probability of cards model, we have 26 cards of same color, that is black color, 26 cards of red color. There are 2 different colors in cards. One is 26 set of black color and 26 sets of red color. Now as I'm repeating again, king, queen and jack are called as face cards, remaining called as non-face cards. These face cards are also called as honored cards. Now let me go to the next slide. If you see, I have drawn, my dear students, king, queen and jack. You can see 26 black color and 26 red color. Total we have 2 different colors in cards, 26 black and 26 red color. Already I have written here. There are 4 different names for the cards. One is 13 cards. A set of 13 is called as spades. I have drawn the diagram here. And the next 13 is called as clubs. And next 13 are called as hearts, heart symbol. And next 13 are called as diamonds. So total there are a set of 13 into 4. That is 13 spades, 13 clubs. This 13 plus 13, 26 cards are of same color, that is black color. And one more color we have, that is 13 hearts and 13 diamonds of red color. This is also 13 plus 13, 26. So 26 black color and 26 red color cards you can see in a deck of 52 cards. Now directly we can go to the first question, my dear students. I'm going and remaining for the next slide for the sake of you, dear students. you see here, let us go directly to the first question. Question number 1. From 52 cards, one card is picked up at random. From 52 cards, we have to take one card. The question is, what is the probability of picking a black card? As we know, there are 26 black cards and 26 red cards. We have 26 black and 26 red cards. I'm showing to you again. Now we have to pick a black card. So out of these 26 cards, we can pick any one card. It can be king, queen, or jack, or 10, or 9, or 8, or 7, 6, 5, 4, 3, 2, and as. So out of this 26, we can pick any one card. Total there are 52 cards. From this 52, we have to remove one card now. That one card must be from black color. The first question says, one card at random is picked from 52 cards. Picking a black card. What is the probability of picking a black card? So as we know, there are 26 black and 26 red cards. Total 52 cards. Directly let us go for the denominator. What is the probability is 52C1. DR in the sense it's denominator. 52C1 in the sense out of 52 cards we are removing one card. Coming to the black cards, there are 26 cards. Let us go to the numerator now. Out of this 26, we are removing one black card. So 26C1, that is nothing but 26 by 52C1, that is nothing but 52. It's totally 26 by 52. 26 into 2 is 52. So 26 by 52 is nothing but 1 by 2. So we can see the first question, my dear students, we have completed. We are picking only one card, that is of black card. So it's nothing but 26 by 52. As we have 26 black cards and 26 red cards, we are going to remove the one. Let's go to the question number 2 now. One card randomly picked. So what I am solving here is all of our basic standard questions. This first class of the probability. Now when you continue like this, the difficulty level in probability questions and a variety of questions will come. That I am going to explain in the coming videos. Now let us see the basic questions now. One card is drawn at random from 52 cards. What is the probability of picking an ace of spades or the jack of diamonds? So one card is picked up at random from 52 cards. What is the probability of picking an ace of spades or a jack of diamonds? Let us see this again. An ace of spades. If you say spades, my dear students, there are 13 spades. King, queen, jack up to 13. Ace is the last one. After 2, we call it as ace, ace or as. So we have, in spades, we have only one as. In spades, we have only one as. So what is the question? Let us see the question now. What is the probability of picking an ace? In spades, we have 13 spades. We have only one ace in that. And also coming to diamonds, jack. If you see diamonds, there are 13 diamonds. That in that 13 diamonds, we need only one. Okay, so my dear students, 13 diamonds are there for us. 13 spades, 13 clubs, 13 hearts. Now coming to the second question. One card is drawn from 52 cards. What is the probability of picking an ace of spades? So answer will be definitely 1. Or in the sense it is plus, and in the sense it is multiplication. So one jack of diamonds. There are 13 diamonds totally, as we know. In the 13 diamonds, we have only one jack, king, queen, and jack. So totally it is 1 plus 1, that is nothing but 2. By the denominator is always 52C1 because we are taking only one card. So 2 by 52, 2 is the numerator. 2 by 52, that is nothing but 1 by 26 will give the answer. We are going for the next question. One card is picked up at random from 52 cards. What is the probability of picking either a red card or a king? What is the probability of picking either a red card or a king? If you say red cards, there are totally 26 red cards. What is the probability of picking a red card? If we ask, In this 26, we have to pick one card. So 26, C1, 26, C1. And when I go for the question once again, one card from 52 cards, picking either a red card, 26 red cards already I have written here, 13 diamonds and 13 hearts, you can see 26, C1, or is asking a king. If you see, there are 4 kings. In these 4 kings, we need only one. But already, we have already taken in diamonds 1 king. That is 2 kings we have removed here because 2 kings are left. In 26 red cards, we can see there are 2 kings. So 2 more kings are left. So from these 2 only we can remove 1 because out of this 26, there are 2 kings. Now let us see here. There are 26 red cards. In this 26 red cards, 52 C1 because we are removing only 1. If you see the numerator, red card or a king, 26 we are removing 1, 26 C1 plus 2 kings are left, that is nothing but 26 C1 plus 2 C1, that is nothing but 28 C1. C1 in the sense nothing but the same, so 28 C1 is nothing but 28. Totally we are removing only 1 card, so 52 C1, that is nothing but 52. 28 by 52 is nothing but, dear students, 7 by 13. So 1 card out of 52, picking either red card of 26 or a king. There are 4 kings, but 2 kings are there in the red cards itself. So remaining we have to go for the 2 more kings. So totally 26. Out of 26 we are taking 1, or out of 2 we are taking 1. Let me go to the next question. Question number 4. One card is picked up at random from 52 cards. What is the probability of picking an ace? One card is picked up at random from 52 cards. What is the probability of picking an ace? So let us go back to the original, the diagram. How many aces are there? If you just check, my students, there are 4 aces. Aces in the sense as, you can call it or ace or as. There are 4 aces, 2 black and 2 red. What is the probability of picking one ace? If it says out of these 4, 2 black and 2 red, we can remove any one. So 4 C1. Let us see the question now. One card is picked up at random from a deck of 52 cards after shuffling. So complete after shuffling the cards up and down, down and up. One card we are removing at random from 52 card. What is the probability of picking an ace? Tell there are 4 aces as we have seen just before in 52 cards. Out of these 4 we are going to pick one. So 4C1 will be the numerator and 52C1 as usual will be the denominator. That is nothing but 4 by 52. That is 1 by 13. Next question. One card is drawn at random from 52 cards. One card is drawn at random from 52 cards. What is the probability of picking a club? Now coming to the diagram, only one. What is the probability of picking a club? If you see here in the diagram, there is one tree-like shapes that are nothing but clubs. There are 13 clubs. Suppose we need only one club. So automatically from this 13 we can take any one. That is 13C1 because we need only one club. If you see the question, one card is drawn at random from 52 cards. What is the probability of picking a club? Club I have shown the diagram here itself. There are 13 clubs. So in this 13 we can take one. So 13C1 by 52C1. 13 into 4 is 52. So that is nothing but 1 by 4. Let's go to the next question. One card is drawn at random from 52 cards. What is the probability of picking a red queen? One card is drawn at random from 52 cards. What is the probability of picking a red queen? Now let us see red color cards. There are 26 red color cards. Now there are two queens in this 26. In first suit, in 13 cards there is one, and one more 13 there is second one. So there are two queens in this 26. The question says, what is the probability of picking a queen? Question is, one card is drawn at random from 52 cards. What is the probability of picking a red color card? Means 26, but we want red color queens. There are only two queens in red color, as you see here. So in this two, we have to pick up one, because we cannot select the black color cards. We cannot select the black because he's asking only for red color. That is 26 actually. In this red color, he's asking only for queens. There are only two queens. So denominator will be as usual 52C1. There's nothing but 52. Numerator will be definitely 2C1. That is nothing but 2 by 52. That is 1 by 26. Suppose the question is, one card is drawn at random from 52 cards. What is the probability of picking a black queen? Same question for red and black. There are 26 black color cards. So 26 we have to pick up one, but if we want only queens, there are only two queens in black cards. So in these two queens, we have to take one. So it's nothing but 2C1. That is nothing but 2 by 52 in the same way, 1 by 26. So we have two queens of black color, we have two queens of the red color. Let me go to next question. These are all the basic questions, very simple questions. Before knowing what is probability and everything, again I'm going to repeat it for you. Probability is nothing but selecting an outcome. That is, suppose when you come for direct example of the probability, today some students may tell it is going to rain, some may tell it may not rain. So out of the two possible outcomes, that is it will rain or it will not rain, at least one must definitely happen. It may rain, it may not rain. So the probability is 1 out of 2, that is raining and not raining, out of two total outcomes. So only one can happen, that is one chance. It may rain 1 by 2, or it may not rain, it may not rain also 1 by 2. That is called a simple example for probability. That means if you go for elections also, my dear students, in elections, the probability that he will become the chief minister or some other person will become the chief minister, they are going to guess based on the total sample spaces taken, what is the probability that he being the CM. Even in weather condition, whether it will rain today, whether it will rain tomorrow, based on the past experiences and based on the total outcomes, they are going to take the probability that it may rain tomorrow, it may rain here, it will not. So like this also we can tell. Okay, now let me go to the next question. One card is drawn at random from 52 cards. What is the probability of picking either a king or a spade? One card is drawn at random from 52 cards. One card is drawn at random from 52 cards. What is the probability of picking either a king or a spade? So as we know, there are 4 kings in these 52 cards and there are 13 spades. Now let us see the diagram again. There are 4 kings, that is 2 black and 2 red, and coming to spades, there are 13 spades. Let us take the first column of the cards as spades, second column as clubs, third column as hearts, fourth column as diamonds. So there are 13 spades, 13 clubs, 13 hearts and 13 diamonds. So the question is, we are going to take only single card. The question is, one card is picked up at random from 52 cards. So what is the probability of picking either a king or a spade? So coming to, there are 4 kings. We have to definitely select one king in the sense 4c1, or in the sense it is plus. Coming to spades, there are 13 spades. In this 13 spades, there are 13 spades, you can see here. In this 13 spades, there is one king. There is one king for us. So when you go for these 13 cards, 13 spades, we are selecting one. So one king is gone here. You're left with 3 more kings, 1, 2, and 3. So let us go to the question now. So one card is drawn at random from 52 cards. What is the probability of picking either a king or a spade? So there are 13 spades. One king from 13 spades we are taking. And remaining out of the 4 kings, there are only 3 kings. So 13c1, that is from spades, plus 3c1. Total it is 13 plus 3, 16 by 52c1, because we are taking only one card. There may be questions where we have to pick 2 cards, we have to pick 3 cards. So as we go on into the video further, we may get the different variety of questions. Let me go to the next question. One card is picked up at random from 52. These are all one card questions. One card is picked up at random from 52 cards. What is the probability? All the cards are always shuffled. Remember, dear students, all the cards are always shuffled. From shuffle cards, one card is drawn at random from 52. What is the probability of picking either a heart or a king? What is the probability of picking either a heart or a king? So coming to this, we have 13 hearts. This is the hearts line. We have 13 hearts, as we are seeing. What is the probability of picking a heart? Means 13c1. In that there is one king, one queen, one jack, one ace. Now coming to the question, what is the probability of picking either a heart? There are 13 hearts. I am going to take one from that, king or a king. Totally, as we know, there are 4 kings. You can see it again, 1, 2, 3, 4. In this 13 hearts, one king is gone. So remaining there are 1, 2, and 3. So totally we can directly say 13c1, that is out of the 13 hearts I'm taking 1. In that there is one king, and also we have 3 more kings. So total it's nothing but 13 plus 3, 16 by 52. That's nothing but 4 by 13. For 4s are 16, for 13s are 52. Now let me go to the next one. I'm going for the next question. Now these questions are with 2 cards. Just now I have seen up to now one card or single card. We're going for 2 cards now. Let's see the question number 8 or something. There are 2 cards, or the question says there are 52 cards which are always shuffled. There are 52 cards which are always shuffled. What is the probability of selecting 2 cards from a deck of 52 cards? Both the cards which are taken from 52 cards must be kings. So 2 cards are drawn at random from a deck of 52 cards which are completely shuffled. What is the probability of picking both the kings? Already we know there are 4 kings. You can see here there are 4 kings. In this 4 we need 2. it did not mention we need black color kings or red color specifically. So we can go for directly 4C2. That is out of 4. We are taking 2. Now see the specialty here. Out of the 4 kings, we are removing 1. So 4 by 52 is the first case. And coming to, it is not the question of or, we need 2 cards, so it is definitely and. So 4 by 52 will be the first case. Coming to the second one, when 1 card is removed from 52, we have 51 cards alone. In this 52, out of the 4 kings, 1 king is gone. We have only 3 kings now. So out of the 4, we are removing 1. Out of the 4, if I remove, say, this one, I have only 3 kings left. So number of cards which are you are seeing on the screen is nothing but 51. It is 52 now. Now it is 51. So directly if you go to the question, it is 4 out of 52. That is 1 by 13 into 3 by 51. You can cancel it with 4. 4 by 52 is 1 by 13 into 3 by 51 is 1 by 17. 13 into 17 is nothing but 221. So 1 by 221 will give the answer. I am repeating the question again. There are 2 cards have to be picked up from 52 cards. Both must be kings. So there are 4 kings actually. And this 4, I have to take 1 in the first step, that is 4 by 52. Again, automatically what happens is 1 card is removed from 52, we'll get only 51 cards, and out of 4, 1 king is gone, we have 3. So 4 out of 52 into, because it is not odd here, we have to take 2 cards into 3 by 51. Let's go to the next question. Two cards we had to pick up from a deck of cards which are completely shuffled. 2 cards we had to take from a deck of 52 cards which are completely shuffled. Both the cards must be spades. So 2 cards we had to pick up. Both the cards must be spades. Now if you see here, there are 13 spades. These are again clubs. These are again hearts. These are again diamonds. We are not interested in all these 3. We want only the first case. That is, there are 13 spades. We are trimming 2 cards from 13. 2 cards from 13. Suppose there are totally 52 cards. If I remove this card from spades, I have total 51 cards here. And out of the 13, we have only 12 left. So I have to remove 2 spades. One more I am removing. One more remaining. So if we go like this to the question, 2 cards are picked up in random from a pack of 52 cards which are completely shuffled. What is the probability that both are spades? There are 13 spades as you have seen in the diagram. There are 13 spades. In this 13, first step out of 52, I am going to remove 1. So 13 out of 52 is the first step. Now 1 spade is gone. We have only 12 spades left. So 12 out of 51 is the second one. So 13 by 52, 1 by 4 into 12 by 51. That is nothing but, we can cancel 4, 3 is 12 again, and 51, 17 times. 3 17 is 51. So after final cancellations, we get 1 out of 17. 1 is the numerator, 17. So probability, as we know, it's always less than or equal to 1. So all the possible outcomes will be equal to 1. So there will be variety of questions, not only this in probability. There are 4 different types. I'm going to tell now what are the 4 types. Already have given a link for you, that is, which contains only balls questions, only the basic ball questions. Today I'm going to upload the second one. This is nothing but cards. So balls, cards, dice, and coins. So the question in probability can be taken either from coins, either from balls, either from cards. So not only this, we are going to get different sets of questions of high level in probability, which I will explain in the coming videos. Let me go to the next question. 2 cards are drawn. from 52 cards. Picking one is a jack and one is a ace. Two cards we have to take now. One is a jack and one is a ace. One is a jack, two cards. Coming to jacks, as we know there are four jacks. Out of these four jacks we have to take one. Coming to us, 1, 2, 3, 4. Out of these 4 we have to take 1. So in the same case again, suppose if I take this jack from 52, I have only 51 cards now. So out of this 51 only I have to take this ace. First if I take this ace out of 52, again in the same case we have 51 cards. In that 51 I have to take a jack. Now if you see the question, there are 4 jacks. There are 4 aces. So 4 by 52 is the first step. You can see here into 4 by 51. I'm going to take the next one. Because there are 4 jacks, there are 4 aces. Out of these 4, 52, but there are only 51 cards now. In this 51, we have to take 1. So 4 by 52 is nothing but 1 by 13 into 4 by 51. So nothing but numerator is 4 by 13 into 51 is 663. Let me go to the next one. Again, one card question came here. One card is drawn from 52 cards, picking a number 3. So from a pack of 52 cards which are completely shuffled, we have to take one card. That card must be a number 3. If you see this again, number 3 is there is 1, 2, 3 and 4. There are 4 threes you can see here. Out of these 4 threes, I have to pick up one. He did not mention the color, it must be a black color or red color. So automatically what happens is, so picking a 3, we have 4 threes as I have shown just now. 4 threes are there here. In this 4 threes, so 4 out of these 4, any one 3 can be picked up. 4 out of 52 is a chance. Now in the same we have one more question. 4 by 52 is 4 ones are 1 by 13. We can write it here as 1 by 13 again. What is the probability of not drawing a 3? We should not have 3 in this. We should not have 3. Now if we just check like this, not drawing a 3. So there are 3s. You can just check there are 4 3s. We should not take this 4 3s. 4 3s are to be cut. So out of 52, 4 are gone. Not drawing a 3. We have only 48 cards. In this 48, we can take 1. So denominator as usual will be 48. 1 out of 48. Now coming to the total probability, if we take out of 52 cards, 52 can be taken, but we should not take the 4 threes. So I am subtracting. So 52 of 52 is nothing but 1. What is the probability of drawing all cards? Means 52 by 52 is the probability of drawing all the cards. So from 52 by 52, we have to remove this 4 because we do not want this 3. So 4 by 52 is nothing but 1 by 13. So 1 minus 1 by 13. Total is nothing but 48 by 52. Because 52 and 52 are there, 48 by 52. We can take like this. Four ones are 4 twos, 4 ones are 4 threes, 12 by 13. This is nothing but 13 minus 1, 12 out of 13. It is the same as this. Let me go to the next one. This is the next question in cards. Two cards are drawn at random without replacement. This is one more model. Two cards are drawn without replacement. That means once the card is taken out, it should not be placed again. So two cards are drawn at random from a deck of 52 cards which are completely shuffled. So out of these two cards, once we take the card outside, that is without replacement in the sense, once we take the card outside, we should not place it again. So what is the probability that the cards are black color? Again, let me show the diagram once. There are 26 black color. In this 26 black, what he is telling is without replacement. What is once I've taken this card, I cannot put it back. So automatically out of 52, I have only 51 again. Again, I have to take out of this 51 one more card. Only we need black cards. We are not interested in the red card here. So if you see the question, there are 26 black cards. Totally out of 52, 26 black out of 52. That is the first one. Into one card is removed. We have only 25 cards. And out of 52, we have 51. So that is nothing but 26 by 52 is 1 by 2 into 25 by 51 is nothing. We are not going to cancel it. So 25 by 51 into 2 is 102. 25 by 102 is 0.24, which is less than 1. That is a probability. So again, I am repeating the uses of probability in daily life is, suppose there is a cricketer who hits several runs in several matches on an average. So the question comes, that means out of 10 matches, 8 matches, he scored 100. Next 2 matches, he scored only 50. Now what is the probability that 11th match, he will score 100? We can go for probability, number of chances. So there we are going to use the probability. In cricket we can use, in weather forecasting we can use it. We can use it in whether asteroids are going to hit the earth. One more probability related to space. So like this in daily life we are going to utilize the probability. Now we are going to the next question. These are different questions, not from cards, but whether the students are able to do it or not, let us check it. Let us see the question. Tickets are numbered 1 to 20. Let us see, they're nothing but film tickets. If you go to in film, there are numbers from 1, 2, 3, 4, 5, 6 up to 300 or 400 in a theater. So tickets are numbered 1 to 20 are mixed up now. So suppose if I pick up, I may not get the required number. Suppose I want 5 number. If I pick up, I may not get 5 because they're all mixed up. Then one ticket is drawn. What is the probability that it is a multiple of 3 or 5? That means the ticket which I am drawing must be a multiple of 3 or 5. So tickets are totally 20 tickets. We have 20 tickets in hand. Out of these 20 tickets, what we are going to check now is whether it's a multiple of 3 or 5. So 3 multiples, let us go. 3 multiples are 3, 6, 9, 12, 15 and 18. Now multiples of 5 are 5, 10, 15, 20. We need only up to 20 because 21 is not required for us because it is only up to 20 tickets are available with us. 15 is repeating here. 15 is repeating in 3 and 5 is a common number. So now total how many chances are there for what is the probability of taking a ticket which is a multiple of 3 or 5? If you just check 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to count this. So 9 out of 20 is the right answer. So tickets number 1 to 20 if you mix up with a multiple of 3 or 5. Suppose I'm going to ask the same question. So what is the probability of drawing a ticket which is a multiple of 4? So 4 multiples of 4, 8, 12, 16, 20. Out of this, any one ticket can be drawn. So I'm having 5 chances out of 20. That is nothing but the probability is 1 out of 4. 1 by 4 is the probability, that is nothing but 0.25. So probability is also expressed in terms of decimals. It's not only fractions. So let me go to the next question. A bag has 2 red, 3 green and 2 blue balls. A bag has 2 red, 3 green and 2 blue balls. 2 balls are drawn at random. What is the probability that none of the balls is blue? So we do not want blue balls. None of the balls is blue. So there are 2 red plus 3 green plus 2 blue. Totally 2 plus 3, 5 plus 2, 7 balls we have in a bag. So there is a bag containing 7 balls. In the 7 balls, what happened? We are going to pick 2 balls. That 2 balls must not be blue. It can be either red color or it can be green color. Red or green is possible here. We can pick only red or green. We cannot take blue balls. So what is the probability that none of the balls is blue? So if you remove or exclude the blue balls, which are only 2 in number, we have 2, that is red balls, 3 green balls. We are not interested in blue balls. So total it is 5. So if you come to the denominator, there are totally 7 balls. In this 7 balls, we are taking 2 balls. That is clear here. So 7 into 6, 7c2 in the sense by 2 into 1 or 1 into 2, you can write it as 2 3s 6, that is 21. Total there are 21 chances, 21 outcomes. In this we are going to take only 5. Why? Because we are excluding the blue. So out of 5 we are taking 2. So 5 into 4 by 1 into 2 or 2 into 1 we can write. It's nothing but 2 2 is 4. So 5 into 2 is 10. So 10 by 21 gives the required answer. 10 out of 21. Let me go for the next one. In a class there are 15 boys and 10 girls, suppose. In a class there are 15 boys and 10 girls. 3 students are selected at random. We have to select 3 students now. Total 15 boys are there, 10 girls are there. 3 are to be selected at random. The probability that 1 girl and 2 boys are selected. The probability that 1 girl and 2 boys are selected. What is the probability? So in a class there are, if you directly see here, 15 boys and 10 girls. 15 plus 10, that is nothing but 25 students. 15 plus 10, we have 25 students in a class. Now coming to the total 25 students, 15 boys are there. We need 2 boys. 2 boys are to be selected from 15 boys. So 15 we have to select 2. So 15C2 is the first one into, and in the sense is nothing but into. Last one is 10C1 because we have 10 girls. We have to select definitely 1 girl. So 15 out of 15 we have to select 2. Out of 10 we have to select 1. So 15C2 into 10C1. By total there are 15 plus 10, 25 as we have seen. From 25 we have to select 3. So 25C3 is the denominator, and 15C2, that is out of 15 boys we are selecting 2. Out of 10 girls we are selecting 1. 10C1 is nothing but 10. 15C2, let me check. So 15C2 means 15 into 14 by 1 into 2, that is 2 7s are 14. 10 7s are 70 plus 35, 105. So into 10C1 is 10, that is 1050. Coming to 25C3, 25C3, 25 into 24 into 23 into 1 into 2 into 3 or 3 into 2 into 1. If there are any cancellations, we just check it. With 2 we can tell 12, to 12s 24, and 25 and 3 we cannot cancel in 23. So if you multiply this, we are going to get 2300. So 105 by 230 we can take it as nothing but 21 by 46. So like this probability, I have explained cards questions to you. Not that all the questions in probability will come from cards or dice or coins or balls. They can be a different variety of questions in probability. Let us see the question. Next question. In a lottery, there are 10 prizes and 25 blanks. In a lottery, there are 10 prizes. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 25 blanks. In this 25 blank, there are some 10 prizes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 are the prizes. So 25 people will be going to take some lottery somewhere. Only 10 are going to get the gift. Remaining may not get the gift. That is the question like that. In lottery, there are 10 prizes and 25 blanks. What is the probability of getting a prize? So when I go for a lottery and take up one lottery, what is the probability of getting a gift or prize for me? So let us check. So totally there are 10 prizes and 25 blanks. So totally there are 35 outcomes. So sample space if we take, there are 35 because totally there are 25 blanks and 10 prizes. So I have given blanks up to 25 and one more. I had to go for one more 10. 6, 7, 8, 9, 10. Now it is exactly 35. Out of this 35, there are 10 prizes. So what is the problem? He did not tell in this 25 blanks only there are prizes. He told there are 35 plus 10, 35. In this 35, we are going to check for this probability. So total it is 35. The denominator, there are 10 prizes. So 5 2s 10 and 5 7s 35. That's nothing but 2 by 7 is a probability. That is 2 by 7 in the sense 7 divided by 2. It doesn't go 0.72 is 14, 6. Again 0, 7 8, 0.28, or you can write it as 0.28. That is a probability. So we have seen for now several questions in probability. Now in the coming video lectures, I am going to upload most of the difficult probability questions which are given in TCS, Accenture, CTS, and all the multinational companies for aptitude test. Thank you.